All right. All right. Nu är vi live alltså. Okay. So welcome to this talk about test-driven development. My name is Jakob Leczinsky, and I work at a company called SeenThis. I'll explain what we do in a moment. So the goal with this talk is to give you all some hands-on tips on how to successfully apply test-driven development in practice. So it applies to junior developers or senior developers who has never really gotten started in a real project with test-driven development. And what I will do is that I will go through 5 bullets of just some hands-on tips on how to get successful with this. And it's things that I've seen that even experienced developers fails to implement or are missing in a real project. So let's see, the 5 bullets we'll go through today, or the agenda for today, is define your strategy for test-driven development, or for your test strategy. Use inversion of control. Always return something useful. Hide any side effects behind a facade. And finally, test your code frequently. So, who am I? My name is Jakob. As I said, I work at SeenThis. I've been a developer since 2008. That means that I made money from coding since 2008. I've been in a number of industries in Stockholm, in the media company called Session, at an insurance broker called Max Mathisen. I made the first iPhone app for my taste, and then I became a consultant. And through the consultant company, I developed a new backend for Dagens Nyheter and Dagens Industri. Actually, I don't think it exists anymore, but we also developed a site called Nordic Tech List, which is like a Nordic Crunchbase. Then I developed the backend for the new dplay service at Discovery. I created the JavaScript bootcamp at Salt together with Marcus Hammarberg, who is still running it. And then I went on and developed an event sourcing system for Flexibla Kontoret, the system unfortunately never got published, but I think it was a really cool product. We made that. And I've been working with the e-krona project for the Riksbank. And now I'm at SeenThis, again with media streaming company. Slightly different angle though than Discovery. So what is SeenThis then? Well, we work with something called adaptive streaming. And basically what it means is that we use streaming technology to serve images and videos over the internet. This is mostly applied in the ad space. And what we're doing essentially is reducing data transfer over the internet and thereby also reducing the carbon emissions. So our platforms are mainly the web and the cloud, and we mainly use JavaScript technology for this. Okay. So test-driven development. I don't know how many have seen it in practice, so I'm gonna run a short demo here, just so we get the feel for it before we start talking about it. And what we will do is develop a to-do app in a web interface. Let's see if I can okay. Obviously, the sound disappeared from the live. I hope you can see this anyway. Maybe I can make it a little bit. Let's see. Hope this. Okay, so the first test says what we have here is to the left we have my editor, and to the right we have this Cypress framework running. We can see all the disabled tests here, and we'll enable them soon. And what we'll see here is just a preview of the web page we're developing. So the first test says it should load the title, which basically means that it should it should display a header element on the page. We see the test starts running here and it fails. That's on purpose because nothing is implemented yet. So let's implement this this code. What we see here is this is a Svelte application. It has a style block, and that's just the way Svelte works. We'll add our markup and our JavaScript above this. So, oops. What we have here is it's a bit difficult to type in this angle, actually. So our first implementation should be this one. Oops. Okay. So test-driven to-dos. You see that immediately the it got displayed on the preview, and let's rerun the tests. And it's okay. It's green. Cool. So let's run the next one. This one says it should have an input text form. The test runs, it fails. So let's try to implement this. So I'll erase our previous solution to this and just add my snip here for. As you can see, we're adding a form and an input field with text type. It appears to the right, Let's rerun the tests, and it works. Now we can continue with this for a while. I think you get the hang of it. So let's just enable a couple of more tests here, which aren't okay. So they start failing. And as you can see, we wanted this one to add a button with the text add. We wanted it to show a default message in the list of to-dos. That it's down here. We have a list of to-dos, or that's what we were requiring our code to have. And we should also have a placeholder. Normally, you would do these ones one by one, but it would take a little bit of time. So let's just. And I think that would be like maybe this one. Oops. I'm not used to this keyboard. So it popped up a bit of things there. So let's see if we can run our tests and see what happens. I missed one thing. What was that? It was the should have a placeholder. So let's jump forward one version of this code. What was the last snippet I used? 5. Let's try 6 then. It should have a placeholder somewhere. Yeah, add a new task. I think this one is actually the one that will even resolve some of the other tests. But as you see, this test is green now. It works. I accidentally added this one as well because it adds actually this is the entire solution. It adds functionality to the buttons and a remove button and so on. So let's just see if we can get everything to run. And it works. And what we actually have here is it's a real functional web page now, a to-do app. I can add stuff. I can remove stuff. So this is like the classical HTML kata exercise, basically, developed through tests. So now we know what we're talking about: test-driven development. So let's move into what were the 5 tips that I will give you. And the first one is define your strategy. And this one is, I think this one is really important, and it applies to the project you're currently working in. So within your project, define what kind of testing strategy you should have. What is a unit test according to your project? How do you define a unit test? How do you define an integration test? What is a stress test? And so on. In what phase of the development cycle should you run your tests? When should you run your unit tests? When should you run your integration tests? Will you use some kind of CI/CD pipeline to run these tests or not? If you get this right, it will become a lot easier. So to understand this, I'll go through some kind of definitions. I don't say that it's the correct ones, but at least how I see some of the most important kinds of tests. And to do that, we must first try to understand what is a test. And I think most of you test a lot more than you actually think you are. Because you probably test your code manually. You write some code, you verify that it works either through an UI like we did, like a web UI or some mobile phone or even the terminal. And then you continue. That is also testing. Then we have what we usually think of when we talk about test-driven development, and that's automatic tests. And there are a whole lot of buzzwords here. Here's some of them that I could just come up with. You probably heard most of them before. Maybe you come to think of some others that I didn't when I wrote this. But you can see, as you can see unit tests, integration tests, end-to-end tests, performance tests, stress tests, and whatnot. So let's take the first one that you typically think of. It's the unit test. And the unit test, it by definition should test a small unit of code. It should be isolated. If you do it right, it should be granular and fast. Unit tests are often quite, before you get the hang of your project that you're working with, they could be quite difficult to get started with. But as your project grows, you will really appreciate your unit tests, and it will become easier and easier. However, there's no guarantee that your entire system or the code as a whole works just because you have a good unit, like a test suite of unit tests. Because by definition, they are testing the code independently, if you're doing it right. So a good complement to the unit tests are the integration tests. And I usually throw in the end-to-end test and component test in this category because I think it's basically more or less the same thing. It's a test that has a larger scope than a single unit. And you're testing that several components or your entire system works as a whole unit. It's often quite a lot easier, at least I think so, to get started with integration tests. You have some kind of vague idea what you want to do with your system, and you kind of write a test that if I send in this data into the system, I want this out. And it's a black box. It covers the entire application flow by that sense. However, they also quite often quite a lot slower than the unit tests, because usually you will have to run up some kind of database to verify that it actually works. It could be like we've seen in the previous example with the Cypress, it actually using a real browser to navigate the page. It will become very slow, especially if you have hundreds of tests. So they can also be very difficult to maintain, because they tend to, if you load your integration tests with too much detail, you will end up with real spaghetti. I've actually been in such a project where the thought of the project was that unit tests aren't good. They only test things in isolation. We really want to see how the entire system works, so let's just do the integration test stuff. And when I came into the project, I quickly realized that was the reason that all the developers were just sitting like this, thinking. Because it became such a mess and so difficult to understand how to maintain this suite of integration tests. So I definitely don't want to skip this, but keep it, think it through, and just make sure that your integration test suite only tests that the things are connected, and then put your energy on the unit tests. We have another category of tests that has become quite popular, especially since Facebook released the Jest testing framework, and that's the snapshot tests. They're really easy to implement. You write your implementation, then after your implementation, you write the test, and it takes a snapshot of the code, and as long as the code hasn't changed, test is green. If the code changes, you get the notification by the framework saying, is this change of the code okay or not? And you have to say if you have to confirm that the change is okay. This is a very good way of validating the application state. But test-driven development has so much more to offer than doing this, because this is not test-driven development by definition, because you won't let the test drive your implementation. The test-driven development is actually first and foremost a design philosophy of how you design your code and not verify that it actually works. They're also, in my mind, too easy to neglect. If you write code and suddenly a snapshot pops and you say, okay, it's probably okay. It's too easy to neglect and not really dive into why this snapshot test really broke. One more category I would like to say something about are the performance tests, or you could call them load tests or stress tests, depending on how you define it. What often happens is that someone says, hey, we need to performance test our application before we go live. And they write a huge performance test suite. They run it once. They're happy with it. And then they leave it to rot until like 3 months later when they try to run it again, and it doesn't work. So if you do this, and sometimes you really should do it, run it regularly, like every night or every weekend or something, because these kind of tests may take a long time to run. It's not necessarily so that you want them in your daily CI pipeline, but find a way of running them regularly. Then, next topic, test coverage. If you read the TDD literature, it's usually quite old, and they say 70 to 80% is often preferred in terms of test coverage. When you come into some project, there's often someone who says, hey, let's measure the test coverage. Well, let's aim for 90% or even 100. And I would say that this is way too much. I would say that 70 to 80% is even way too much in a modern project. Because in a modern project, we usually make use of a lot of frameworks. So, and the frameworks comes with a lot of boilerplate code, which is like trivial, and you shouldn't spend your time on writing the test code for such things. I mean, you can have like one test to just show that your server actually did start. It doesn't have to go through everything. Finally, on this strategy topic, I would like to talk about something that we'll come back to throughout this talk, and something that I think of daily. It's a technique called divide and conquer. And it's all about dividing a complex task into multiple subtasks, and keep dividing it until it becomes trivial to test. I would like to think of it, deal with any complexity later. If you find some kind of complexity that's difficult to test, find a way of just dealing with it later. And it will eventually become either it will become trivial, or it will have become pushed so far away from the heart of your code so that you can test it manually somewhere, maybe take a snapshot if you're really paranoid, and then leave it. Oh, I'm always ahead on my slides when I talk. So we've been talking about finding a strategy for how you work with your tests. Next one is really important. It's inversion of control. Inversion of control is like a design principle. In a more general term, where you like control the creation of instances of code outside of your scope. And we will come back to this over and over again throughout this talk now. The implementation of inversion of control that we'll use in test-driven development is often dependency injection. Dependency injection is that you inject your resources. It could be an instance or something, or like a database driver or something, into the scope of the code that you're about to test. You can do it either through a constructor or through setter functions in object-oriented programming, or it could be like a function parameter. And this is very close to the old saying, composition over inheritance in classical object-oriented programming. So why is this good for testing? Well, it promotes loosely coupled code, which happens to be not just a good design pattern, but also a good pattern for implementing your tests. It will make whatever you want to call it, stubbing, mocking, faking your resources easy, or easier at least, and the code will actually become testable. So let's have a look at what this looks like in practice. This is some Python code. I chose to do this in Python because Python is a really clear and easy to understand language. And this is what something could look like when you just start out coding without having tests in mind. It's a function to create a user out of a person. In this case, the user is just basically the same thing as the person. What we do here is that we create a SQL connection to a SQLite database. We insert a name into the user table. We make the commit, and then Python is a dynamic language, so we create a user object kind of and return it. This code is not easy to test. Now, in this case, we're using SQLite, so we're referencing just a file on the file system as our database. But say we were using a Postgres database instead. Then we would have to set up some kind of external Postgres process. You probably want to configure this in some way so that you know that you are in your local test environment, so that you hit your local Postgres database. And it will become a mess. It's something that you probably would like to do in an integration test, but definitely not in a unit test, because then the unit test is not isolated anymore. It's dependent on a separate process running this Postgres or SQLite database. So how can we solve this? Well, let's use some divide and conquer mindset and push some of the complexity to the side. We combine this with some dependency injection, and we, oops, I'm ahead again, and we end up with this. So now you can see that we inject our connection into this. This makes a whole world of a difference, because this connection we can easily replace the connection. We can even mock it or stub it or make a fake connection with the same interface as the old one, and have total control of the code under test. So we don't need to use a real database anymore. But it's still not perfect. Mocking a database connection can actually be quite difficult. And the same goes for like an HTTP client or a message broker client or something. They're usually made up of some complex objects that return some complex other objects, and mocking that can be really, really difficult. So let's divide and conquer a little bit more. As always, we can abstract this code by using an interface. Now, Python is a dynamically typed language, so we have what do you say? It's not an explicit interface. It's like more an implicit one. But we demand that this repository we send in should have a save function that takes a person and returns a user object. And this is a pattern called a repository interface. In this case, it became totally trivial. I mean, you can argue that what are we actually testing here? But we'll soon add some complexity to this, and it will make sense. Now it becomes really easy to write this test. We can create our own fake repository here that's actually using the same interface. In this case, it returns a positive operation. Everything works, but it could throw an exception if we want to fake that. We could use some kind of mocking framework to maybe save a line or two. But personally, I tend to build my own mocks. We can now test this code using our fake repository, and it returns our user. And we are kind of fairly certain that this works, at least. We could add even more complex tests if we really want to make this, if we really want to be certain that this works. And if we use the typed language, it would make us even more certain that it works, because you couldn't just send in anything. Finally, we want to implement this interface. And this save function actually has the same code as we had in the beginning before. Now, the good thing about this, I mean, you could argue that we have actually made the situation worse by splitting up the code into separate modules and make the cognitive load even higher to understand what's going on here. But what we actually have allowed ourselves to do here is to put this code, the actual implementation of the user repository that interacts with the real database, we can put this in a separate module or even a library. And this library can be tested through integration tests completely independently from our implementation. And when we run our test suite, we can, for instance, run on every commit, say, our unit test, because they're really fast. It takes a second. And then when we push to our remote repository, I say that as a Git, for instance, we can automatically run our integration test and actually make sure that everything works. In this particular case, we're testing a SQL database, so this will hold true. Or let me say it like this. As long as you're not putting too much of your business logic into the SQL code, in the SQL layer, this will work really nice, because then you won't run this test very often, because it won't change. But if you fall into the trap and do the classical relational database system with a lot of SQL logic that references tables back and forth, then you will end up with a whole lot of logic in your SQL layer, and you won't benefit from this. But in 2022, I see no reason to do that. The reason relational databases became so popular was to save space on disk, and it's not an issue anymore. Okay, let's add some complexity to this example. Let's say that our create user function should also generate the user ID. So the person type that we send into this function doesn't have an ID. We should generate it, and it should be saved into the database, and then we should return the user object with both the ID and the name. We have our old test, and now we create a new one. It verifies that the object returned actually has this ID. You can see something very interesting here. Instead of a repository, I'm injecting a context. And the context contains both a function called idgen and a repository. And it's just instead of having two parameters in the function, so I'm injecting a context. I have this ID generator here, and it will generate just a string of random letters or alphanumeric string. What we're actually simulating here is a dependency injection framework. Like if you take a popular one, Spring for Java, it's not much of a difference. It's just they're doing basically the same thing through annotations. But this is hand wiring our own thing. This is how it works, more or less. So you define all your, typically what you do, you make your service that is creating this user. You inject your context with all the external dependencies it has to handle. And then you create all these database connection, HTTP clients or whatever it might be outside in a scope far away from your implementation code, like in your main file or something. So we've seen this in Python. Does it work in some other language? I would say yes. I've still yet to come over a language where I haven't got these kind of methodologies to work. This is an example in Java, doing basically the same thing. The big difference is that Java is stronger typed than Python. So in this case, we get a lot for free. We have to create a explicit interface, though, which I personally like. But we also get some type safety here. So if we were paranoid in the Python example, we'd probably have to write a few more tests to actually verify it works as expected, and also have some implementation for it. In the Java case, it's a compiled typed language, and it will just the compiler will crash, or the compilation will crash, unless we follow the rules we have set up. Speaking about frameworks, then should you use your own dependency action framework, or should you use something out available in public? This is a bit controversial, but I would say I generally prefer to do it myself. Normally, you should pick something out on the street or out on GitHub at least. But for these things, I usually, it's so easy. It's just a map of things that you send into your service, and you can, why not do it yourself? But with that said, if you're using some kind of framework, like say, for instance, Spring Boot in Java, or I don't know, Django in Python or something else, stick to the dependency injection framework in that it comes with that framework, because otherwise you will just mess up with your colleagues. So if you're using like Spring Boot, stick to Spring Boot. Okay, we've been through define your own strategy, use inversion of control, and now the third thing I see that even experienced developers fail to do is to always return something useful from a function. Avoid the void. Yes, this will make your code from a testing perspective a lot cleaner. It will also declare or promote a declarative functional style, which was at least a couple of years ago very hip to do. But I still think it's important. I mean, imperative code still has its place, especially if you're working with high performance stuff, but declarative style is usually a lot easier to read and reason about. Just what I said. It's easier to read and read the code generally if you return something. So let's have a look at some example. This is some JavaScript code. We have a function to update a phone number on a contact. The function takes a contact ID, it takes a phone number, and then it takes the magic context that we inject into the function. From the context, we extract our contacts repository. We get the contact by using the getById function, and we update or append the phone number to our contact, and finally we use the repository to save this contact. And this is something that you actually see quite often in code. You have a save function. The one who wrote it doesn't see the value in returning something useful from this save function. Our update phone number returns void. Actually, that's not quite true, because you see this magic async keyword here, which tells in JavaScript world that this function actually returns a promise, but it's an empty promise. So it has some kind of a value in this case, because you can verify that it succeeded or not. It's a resolved or a rejected promise that you will get back. But the idea is that we're not really returning anything useful here. If we have a look at this test, the way we have to test it is that we must make sure that the save function has been called. So we're using this hasSavedUser variable here, which is false from the beginning. And then we have our fake repo, and our save function will toggle this variable to true. And when we run the test, we can verify that hasSavedUser variable is true. It works pretty good. It will work for this single test. But we will run into problems when we add several more tests. Then we'll have to find a way of toggling this back to false every time. You can do it easily by some kind of before each function. But it's still something that we'll have to mess with. It also adds some cognitive load to your mind when you're developing this. You have yet an extra variable to take care of it, when you think about this code. So this kind of code can actually become really messy after a while, especially if you have scenarios with several functions that are called and switching state like this. A mocking framework might help for a while, but still, it's still problematic. What if we instead return something useful? This is almost the same code, but the same save function here will return a user. Oh, no, it's a contact. Our test code is not using this mutable variable. And we just run the code and we verify that the new number we got, or we inserted into our function, is the same as the updated contact phone number. That's it. And when you add lots of tests and have more complex code, this will make a huge difference. Okay, we've gone through define your strategy, inversion of control or dependency injection, always return something useful, and the next one is quite related to the dependency injection stuff we've been talking about, but we'll talk about it again from a slightly different angle, and it's to hide any side effects behind a facade. So the problem with external dependencies is that if you call your test code with external dependencies, it will make the test suite quite slow. Say you have an HTTP client that you call over the internet against some API that you're using, and you're basing your test on this. It will be quite a lot slower than just running a fake. That will be instant, more or less. Even worse, this resource that you depend on might not be up and running when you run your test. So your your continuous integration server actually crashes, and you have all hands on deck because everybody is supposed to correct the error. It could be something really important. Maybe someone is calling you up in the night to correct this, and your code was working all the time because you were dependent on some external resource. They're also quite often difficult to fake or mock. We've been talking about this. These kind of interfaces like HTTP clients or similar things are quite often difficult to mock. So this is some test code. Again, it's JavaScript that lists universities by country. It's using a public API from Hippo Labs to just list. What comes out of this is like JSON objects with some data related to universities. We have this search by country filter that we're using. We're calling the standard JavaScript fetch function to which is an HTTP client. To fetch this, we get a response back if everything is okay. We parse the response and map this to a list of names, which we return. However, this is quite difficult to test. But what if we instead inject our context again, where we have some kind of HTTP client? I mean, we could inject the fetch client, but what if we have our own interface? And we say that the response from this interface should have some kind of payload. which contains these universities and from where we can extract the name. This is our own decision, so this is not exactly the same interface that Fetch is using. It's something that suits our application. We can fake it easily. Say we want the status out and we want the payload. And it's easy to create this test and test. The implementation of this would probably look like something like this. This is our HTTP client using the fetch, the standard fetch function, returning something that confirms this to this interface. Fair enough. This could be tested with injecting fetch directly, but we have made an abstraction here that is quite important. We can improve this HTTP client without affecting our test, because when we improve it, it still confirms to our interface that we have defined. But this version of the HTTP client, it's still using the fetch, but it also contains a timeout, which fetch doesn't do in JavaScript. If you use Axios, you have one, but the vanilla fetch, you have to supply an abort controller. We have also added some nice things like a default get function, a user agent that you should probably have for your system, so that you, I mean, it's best practice. So this also a default timeout. So this is a vastly improved version of our HTTP client, which we have improved without changing the interface. Our test is unaffected. So for several reasons, wrap all your external dependencies behind some kind of facade. They will become easier to test, and your system will become easier to change in the future without affecting the tests. It's not only HTTP clients. Something else that is quite common in some applications is that you have time-dependent code. So do the same thing with any date classes or so. I know in modern Java, in Rust, in probably, yeah, if you're using some of the more modern date libraries in JavaScript, you don't have to wrap them. But the general case, wrap these things. Finally, tip number 5, test frequently. This is so important, to test your code frequently. Run the test as often as possible. You definitely want fast feedback from everything you do in terms of tests. So I will show you what it looks like when I code. This is really small now. Okay, and let's. So what I have here, this is some Rust code. It's just the classic FizzBuzz kata. It's a really simple test-driven playground. And what I will do here is I will start a watch. So it just ran the test suite. And since Rust is a typed language, it actually didn't even compile. Let's enable this test. Oops. It's the keyboard again. So it runs again instantly. I got the feedback instantly. Still the compiling error. It's because this FizzBuzz function should return a string. So let's just return a string. And to satisfy the test, we need to return 1. Boom, it works. Okay? Let's try with 2. It doesn't work. It's because we have a very naive implementation of this. Let's try our input parameter. It works. Okay? That's according to this kata, it should return fys for number 3. It doesn't work. So yeah, you get the idea. Let's just see the whole thing. You see, I walk in with very small steps here and get continuously constant feedback from what I'm doing. Also, I have my editor set up so I can run the test from inside the editor. So if I don't have this running watcher, I can just run the test like this. This works for most languages I've been in contact with. This is Rust. I have a Rust watch here, but in JavaScript, Java, Python, Go, there are tools for running these watches in all of these languages. So that is something that I think you should do. And I'm using Vim here, but it works completely fine in Visual Studio Code, IntelliJ, Eclipse. If anybody is, God forbid, is using NetBeans, it will work there as well. So usually through some kind of a plugin. So that is a way of getting fast feedback and really practice to get this going, this flow, because it's actually quite fun. Keeping it fast, it's also part of this running this frequently, because if your tests are slow, then you will lose focus and you will lose your momentum. So it's really, really important to keep your code fast, both your test code and your implementation code. Just keep that in mind. That's also why you maybe want to run your unit tests very frequently, but maybe your integration tests not so frequently. Use a CI pipeline. Today we can use a lot of several cloud providers are providing us with CI pipelines, like GitLab have actions, GitHub. GitLab also have their version. We can use Circle CI, Jenkins, Bamboo, ThoughtWorks has this Go server and things like that. So setting this up so that your team, your code actually, you verify that your code actually works on something else that your own machine. It's important. It's also important that you, in team collaboration, that you do this. Finally, almost the last slide in run your code frequently, I would say use Git Hooks. It's something built into Git, and you can add shell scripts that are triggered in certain phases of the commit cycle for Git. I usually end up using pre-commit or pre-push, but there are several steps to this. What I usually do in pre-commit is, if I'm using JavaScript, for instance, I run the linter, I format my code so that I know if I commit code, this code has passed the linter and the formatter. So everything that actually goes into my Git, local Git repo, is actually, it looks fine. Running the test suite, maybe not. Even the unit test will take too long. But pre-push, before I push my code to the central repository, I definitely want to run all the tests. So my shell script that I have in my local Git repo will trigger all the tests to run so that I know that I'm not pushing bad code to the central repository. And if everybody is doing this, then you probably won't have that many fails on your build server. You might have one or two because this code might work differently running on the cloud server than it does on your local machine, but mostly not. So that was the 5 tips I have. Those are based on things that I've seen throughout the years that where a lot of developers fail. It's define your own strategy within the project. Each project should define their own strategy. Use inversion of control or dependency injection. It opens up so many possibilities. Always return something useful from a function. Hide any side effect in code behind a facade. And run your tests as frequently as possible. That's it. Thank you. Do we have any questions or comments? Yeah.
Yeah, if you're working on a large code base and a lot of work involves maintenance, updates, changes, did you say having a test for every ticket you're working on? If the ticket says change this in the website, have a ticket, so you have a test.
Yeah, so the question was whether I should have a test for every ticket. Yeah. It depends. I would say that generally yes, and not only one test, but I would maybe set up an depends on how you work. Some teams actually work with something like Cucumber, or something similar to that, where you can actually map a test to a user story. But I would say that maybe I should at least think of setting up an integration test, if it makes sense. And then when I'm developing the code, I try to do unit tests wherever I find that it makes sense to create a unit test. Sometimes it doesn't make sense. I don't want to test any framework code or boilerplate code, and if that is all that I'm changing, then no tests. But generally, it depends. Yeah. Yeah.
I know there are some debates about whether or not to test private functions.
Yeah.
Like object-oriented.
Yeah. I would say no. So the question was whether to test private functions or not. In my mind, I mean, it's my opinion, and this is something that goes into the strategy that you should define within your team. Should you test private functions or not? I tend to say no, because it will make refactoring your code so much more difficult. And it doesn't really make sense anyway, because you want to test the public interface, so as long as that works, your code will work, right? And if you have some private function that is so complex that you cannot figure out how to test it through the public interface, then you should break that out in some kind of other module which has its own public interface, and you can test that. Yes?
Do you only test best case scenarios, or do you tend to also create tests for worst case or trying to break your code? Like if it expects an integer, do you give it a number that is bigger than the normal 32-bit integers
Yeah.
to see how it handles it?
Yeah, so the question is whether I test only the happy cases or even the bad cases, and like integer overflow or something like that. I try to. I mean, we're all human, so we tend to think of the best possible ways. But I try to come up with what could actually go wrong here. Then it also depends on the code that you're writing. if you have logic that is really sensitive to these kind of things, then I definitely would like to test that. But sometimes it's not something that is just as important. But yeah, I try to do it. Yeah. Yes?
You mentioned that when using a framework, you should pretty much always use their own dependency injection system.
Yeah.
So in the cases where that's an issue, what do you do?
So the question is whether, come back to this, if I should use my own framework for dependency injection or use a provided framework.
In cases where you're stuck with a framework and their dependency injection system, how would you like apply your principles of custom-driven development?
Well, if I am using a code base where there is already a dependency injection system or framework, I will use it, because having several different ways of doing it is not a good design. But if I'm designing something from scratch, from my own, then I would at least think of it, of doing it, rolling my own. For instance, I wouldn't probably start something in Spring Boot. I would probably use something more lightweight and roll my own. Spring Boot is fine. It's a very good framework, but it's not my choice. So yeah, but if that is what we're working at the moment, then yes, I would use it. I wouldn't introduce my own. Yes?
Do you have many cases when you don't do test first?
Yes, often. And in a way, I think you must earn the right to skip that. I think. Oh, sorry. If anybody remote didn't hear the question, is there any cases where I don't write the test first? And the answer is yes. Quite often, actually. But with that said, I really think that you should learn how to write your test first, because it will make your code, the design of your code, completely different. So once you have really learned how that code should look like, what testable code looks like and how it works, then I think you're free to write the test afterwards. So if you and I cooperate in some kind of project, I honestly don't care if you write the test first or not. But I do care about how the code looks. And writing the test first is an excellent way of learning what good code looks like. Yes?
In most companies, tests are, well, not priority.
Hmm?
They're more of an afterthought usually. How do you convince the company, your co-workers, the team to write more tests?
Okay, so the question is, in most companies, it's not a common practice to write tests, or at least not in a test-driven fashion. And how do I convince my colleagues to do it? By doing it myself. And constantly trying to improve or like build pipelines and just making more and more code covered by tests. Try to cooperate with my colleagues and really say, we should have a test here. Just bring it up slowly, because you can't change this overnight. It will have to take time. Oh, yes. Any more questions? Yes, one. Okay, so the question is if I have any favorite plugins for VS Code. I'm not a VS Code user. Sorry. I only occasions when I use VS Code is when I cooperate with others online. They have this really cool live share functionality, but otherwise I use Vim. Maybe somebody else knows. something good. Okay. Do we have any more questions? Okay. In that case, I say thank you from me and from SeenThis and from Goto 10. Thank you.